Hi viewers, welcome to my channel Naveen Velchuri. Today we will discuss about the design and implementation of 2-input NAND gate by using Mentor Graphics 2. For that, first of all you have to select X Manager Enterprise 3. In that, click on X Start. In that you can design your project in any session. Default you can take, or you have some new session creation is here, you can create some new also. I am using default session. In the host I am giving the IP address which was available with your institution, you can give. And here the protocol you have to select as SSH, and username I am giving whatever the user is assigned to you, that you have to give, and password also you have to give that one. And go for the execution command. In that, xterm Linux type 2 you have to select and go for run. When you did, and then X Manager Enterprise 3 is opened. Here the user 5 is attached with your local host. Then you have to use 3 commands to enter into the project navigator. For the first one command is csh, and second one is you are linking up your host with all the source which is available with your Mentor Graphics tool. That is the second one. And you have to go for the third command, that is design manager with IC implementation. For that, click on that one. Then you will get a project navigator will open. In that you can create a new project, and you can add a local library to that, and standard libraries, all those you can do. That was already available in the previous video. Now go for the designing of NAND schematic. So to do designing of NAND gate, here two cells are created. One is NAND schematic and second one is NAND test bench. For that I created here. Once again I will show that how to create all those things by removing this. Now see, there one project I have created. For that project, standard library generic 13 and standard technological library both are added together, and one user library I have created to do all the experiments or designing of the circuits. That name I have given as in local. In that right click on that local user library and go for the selection of the cell. I am going to create 2 cells to do a NAND gate designing and verification or simulation of NAND gate operation. For that I require the 2 cells. One is called as schematic and second one is called as test bench cell. I am creating one cell, that is schematic cell I have created. And once again right click on the user library and go for creation of the cell, and one more I am taking, that is TB cell, test bench cell. Now I have created 2 cells. Now that schematic cell, NAND schematic cell, is used to design your schematic diagram or circuit, and also to generate the symbol. For that right click on NAND schematic and go for the new and select schematic. You can give some name, or you can default you can use the schematic name which is available here, and click on OK. Then the workspace is available with you. In that you have to place all the circuits what you require. If you observe the circuit how it will be available for the CMOS NAND gate, I will show here. So this is the CMOS inverter, and here this is the CMOS NAND gate circuit. In the CMOS logic, pull up network and pull down network we have. In the pull down we have the two NMOSes, because here we are designing two input NAND gate. That's why two NMOSes we are using in the pull down network, and two PMOSes we are designing in the pull up network. So I require two inputs, one output, two NMOSes, two PMOSes, and VDD and ground. These all the terminals components all together are available in generic 13 library. For that, you can go for add instance folder, or you can directly click I button in your keyboard of your PC or laptop. From that, go for generic 13 and select symbols. In that symbols, you pick PMOS and place anywhere in the place. Both should be in the parallel in the NMOS. That's why I kept both will be in the parallel view. Now click on escape to paste them. Click on in any space of here, then both will be coming under green color. Now those are pasted here or sticked here. Now right click on each and every component to change its width value. So always put 0.52 micrometers, 0.52 micrometers U for PMOSes. .52 U for PMOSes. And similarly, take once again add instance folder and pick NMOSes, and NMOSes should be connected in series connection, and click on escape. Only two we required. So to view all the components what you have placed, click on view all. Then what are the components you placed, those will be appeared nearly. Now to give input and output ports, go for input port and add port in. Here I require two inputs, that way I am taking the two input ports, and click on escape. Once again pick output port and place at the outer side. Click on escape, and you require supply voltage. For that, from the right side go for the library and select generic library. From that you can take VDD value and also ground value. Now these are the components what I require to design our complete designing of CMOS NAND gate, two input CMOS NAND gate. Now these are the components I required. I took all the components. Now you have to connect these terminals. For that you can use here these wires, or you can directly connect terminal to terminal. So both are in the parallel connection, so I am directly connecting here. So this node is not correct, that's why I am keeping that VDD component above our line. You can, whatever the unwanted things you want to delete, just select that one and click delete. Now I am moving that component upward, and now I am connecting them, and VDD is connected here. Similarly these are joining here, connected to the ground. Now this output is connected at here where the drains are interconnected. And output is connected here. Similarly, I have to connect the input values. One input is connected here and another input is connected. One PMOS and that input is common to an NMOS. Similarly, this is connected to NMOS. Now for this, that input we are going to connect like this. And whatever the fourth terminal we have for the FET MOSFET, that you cannot leave empty. That's why you have to connect PMOS substrate terminals to the supply voltage and NMOS are connected to the ground. Now this is our required circuit. Now you can give the names for all ports. For one I am giving input A, and for second one I am giving as input B, and for output I am giving as out. Now I have given all the names are assigned together, and for NMOSs you have to give the width also. Initially I have to give the width before connecting the substrate terminals. Select that one, right click on that, and you have to change the width as 0.26, exactly half of the PMOS you have to assign. And after that you have to connect now you can click on check and save. Here if you are not getting any error, now your design is correct, or if you are getting any error you can track that error and you can edit your circuit. Now you can close that report. Now for this circuit what you have designed for a 2-input NAND gate by using a CMOS, for that you have to generate a symbol. To generate the symbol, go for add icon here available at the topmost, go for add and take the fourth option here, generate symbol, and generate symbol here select or enable these boxes, replace existing to activate your symbol, and save and edit option, and choose one shape for your circuit. Here I am designing 2-input NAND gate, that's why I am taking AND gate, and for AND gate output is bubbled together, then we will get the NAND gate, because NAND is an opposite operation or an AND gate, that's why output I am placing some bubble. Now whatever the symbol that was generated here is your required NAND gate symbol. Now save that symbol. Up to what you did is done in the schematic cell. Now the designing of schematic diagram and here the generation of the symbol is over, and the work of the first cell is completed, and whatever you did that is available here in the project navigator. Now we have to analyze and simulate whatever the circuit you have designed. For that you have to choose TB cell. Go for TB cell, right click on that and go for the new and take schematic. Same whatever the process you did in the previous cell, same process you have to do here, but the selection of symbol is not from the generic, because here you are analyzing the symbol which was designed by you for your designed circuit. That's why go for instance and select your library and pick the symbol which was available in the schematic cell. Now place that one and click on escape to paste here. Now similarly take input ports, connect them and also connect output port. Change its respective names based on your requirement. And also output port also I am giving some name as out. Now connect them with the symbol terminals. Now we have to assign some source values for what is A and what is B, and also I used some VDD supply in the circuit design time. For that we have to assign some value. All those to do, we go for library available in the right side, go for library and take from the generic library. VDD we have to keep a part, and for that we require the connection of ground, so we have to keep ground also, and we require two grounds to connect input sources. That's why I am taking the two grounds here for both input A and input B. Now come back and go for sources library. From that sources library take DC voltage to use VDD and make sure its value should be maximum of 3.3 volts. Now we have to connect its negative terminal to ground and positive terminal to VDD. So voltage whatever we used for VDD is completed. Now to represent the input and input both AB combinations, I am taking a pattern as source for the first one and also for second one. And you have to connect the first one positive to first input and negative to the ground, and for the second one also negative is connected to the ground and first one is positive is connected to terminal. Here what are the combination of inputs we have in the NAND gate is this one. If you observe the truth table for the NAND gate, see that A and B, A is 0, B is 0. Then what is the output you are getting? 1. Similarly, any one of the input value is 0, then automatically output in the NAND gate is 1, and both of the inputs are equal to 1, then output is equal to 0. For that combinations I have to keep A as 0 0 1 1 and B as 0 1 0 1. So same I am assigning here. So for A I am assigning the pattern as 0 0 1 1, and for second input that pattern I am giving as 0 1 0 1. So these two are completed. After giving all these values, you go for check and save. Then also in the previous session, similar to that, here also one report is generated. In that report, if there is no error, so your designing of the circuit is well and good. Then close that report and go for simulation. Here that simulation option is available at the right side. Go for simulation and select the new design configuration, click on OK and click on OK. Then the edge space is over here. Now you have to analyze this circuit. To analyze this circuit, we have analysis option available at the right side. Go for analysis. In that disable OP, and you have to do two analysis. One is DC analysis and second one is transpose. Here in the DC analysis, select DC and sweep type you have to select as source. Now whatever the symbol is available here, keep that symbol in the sources. Here V2 is one source, I keep that, and I have to give lower value and maximum value for voltages 0 to 3.3, and their space or separation I am giving as 0.1. And I am selecting one more source because I have two inputs here, and keep on second source. Same you have to assign the values as 0 to 3.3 and 0.1. Now come to bottom and click on apply. Again go for the second transpose analysis. Give the start time as 0 nanoseconds and maximum is 1000, and interval in between them as 10 nanoseconds, and come down, click on apply and click on OK, and then you will get a notification here your simulation is correct. Then simulation finished you are getting here, see in the bottom. And now you have to assign inputs and output and also symbol. By selecting control, select input A, input B, symbol and output, then go for outputs icon which is available in the right side. In that you have to take the analysis, two analysis you have applied. One is DC, select DC and take the type as default, and the task what you are doing plotting the waves, so take the plot and click on add. And again you have to select only symbol here and go for the type as power and click on add. Similarly you have to select once again all these schematic selections and take the transpose as analysis and click on add. Similarly symbol only and take the type as power and click on add, and come down and apply OK, run you have to click. Then also you are getting some simulation finished here. Now in the right side go down and click on run L to run your simulation. After that in the down click on view waves, then automatically whatever the inputs and outputs you have give, based on that output you are getting based on the combinations of the input values. So to get a clear representation, close the automatic generated waves and we have to generate once again. Select this trans, I am running first input what I am giving 0 0 1 1, and remaining all I have given once, and second one 0 1 0 1 I have given. And now output I am getting here as when 1 1 is happening in the input combination, then only we are getting output as 0, and remaining all times I got the output as 1. So this is the output of 2 input NAND gate. This is transfer analysis. Now in the DC analysis, input A, input B, and this is the output we are getting. Like that you can design any of the circuit by using Mentor graphics tool. So thank you for watching this video.